At S.T.P, that is standard temperature and pressure, how many liters of hydrogen will be obtained from the reaction of 500 cm³ of 0.5 molar tetrazosulfate 6 acid with excess zinc metal, given the gram molecular volume of hydrogen gas to be 22.4 dm³. Solution. In the question above, we are made to understand that tetrazosulfate 6 acid reacted with excess zinc metal in which hydrogen gas was obtained. So the first thing to do is to write out a chemical equation, a balanced chemical equation showing the reaction between tetrazosulfate 6 acid and zinc metal. So let's do that. Tetrazosulfate 6 acid, that's H2SO4, reacting with excess zinc metal plus zinc to give. So when tetrazosulfate 6 acid reacts with zinc, we'll be having zinc sulfate and hydrogen gas. So zinc. Okay, after writing a chemical equation, the next thing to do is to check if the equation is balanced. Looking at the equation above, we have 2 atoms of hydrogen in the product side, and in the product side we have 2 as well. In the reactant side we have 1 atom of sulfur, 1 in the product side as well. In the reactant side we have 4 atoms of oxygen, same with the product side. For zinc we have 1, and in the product side we also have 1. So we can say this equation is balanced. Now after writing a balanced chemical equation, what is the next step? In the question we are to determine the volume, that since they said how many liters, that is volume of hydrogen. Meanwhile, we are being given the molecular volume of hydrogen gas at S.T.P. So to attempt this question, we'll be making use of the formula that says moles equals volume divided by amount at S.T.P. So amount at S.T.P here is same thing as the gram molecular volume of the gas. It can be stated as volume at S.T.P or molar volume of gas, still referring to the same thing, which is 22.4 dm³. Now this is known, the volume of hydrogen is unknown, and the number of moles is unknown. Do not forget that the volume is what we are being asked to calculate. So to apply this formula, we need to know the number of moles of hydrogen gas that was produced. The equation above shows that 1 mole of tetrazosulfate 6 acid will produce 1 mole of hydrogen gas based on the equation above. But what if we now have 0.5 molar of H2SO4 with a volume of 500 cm³? How many moles of hydrogen gas will be liberated? So what we need to do next is to calculate the number of moles of tetrazosulfate 6 acid that reacted with zinc. To get that, we'll be using the formula that says molarity equals moles over volume. If the volume is in cm³, then we'll be multiplying by 1000, but if it is in dm³, we won't be multiplying by 1000. So let's write out the formula. I say molarity equals moles divided by volume. And do not forget that if the volume is in dm³, that is 1 liter of the solution, we do not need to multiply as we'll be doing now. But here we are given in cm³, so I have cm³ multiplied by 1000. So let me quickly chip in this. This 1000 is gotten from the conversion of cm³ to dm³, so as not to be confused. And let's proceed. Number of moles, do not forget it is moles of H2SO4 we need to get first. Then we can see from here, making moles the subject, say moles equals molarity, we are cross multiplying, times volume in cm³ divided by 1000. The moles of H2SO4 is then equal to the molarity given in the question, which is 0.5 multiplied by the volume. In the question it is 500 centimeter cube, so we have 500 divided by 1000. So calculating this, we have 250 divided by 1000, which is equal to 0.25, and our unit moles. So with this, we've gotten the moles of H2SO4 acid that reacted with the zinc melter. So now the next thing to do is to determine the moles of hydrogen gas that will be liberated. So in the equation above, 1 mole of H2SO4 will liberate 1 mole of hydrogen gas, then 0.25 moles will liberate x moles of hydrogen gas. Definitely it's still going to be 0.25, but I would like to go through the process step by step because of situations in which the moles won't be the same in a case like this. Let's proceed. 1 mole of H2SO4 liberated 1 mole of hydrogen gas, then 0.25 moles of H2SO4 will liberate x moles of hydrogen gas. Cross multiply here, taking this to be an equation sign, we have x to be equal to this with this and this and this, then we have 0.25 multiplied by 1 divided by 1. Actually from here we can just say the answer is 0.25, but we are doing this in situation whereby we have different values as the mole in the equation. So multiplying this, calculating this, we have 0.25 and the unit moles. And we've gotten the moles of hydrogen gas produced to be 0.25. So the next thing to do now, based on the formula we written above, that is, let's try the formula again. Moles equals volume over amount at S.T.P. We've gotten the moles from our calculation to be 0.25 and the amount is given in the question, which is 22.4. So we say volume of hydrogen gas H2 equals the moles 0.25 multiplied by the amount at S.T.P, which is 22.4. In calculating this, we have 5.6 and the unit dm cube. This will be serving as the final answer. So with this, we've come to the end of the solution to the question. It can be concluded that 5.6 dm cube of hydrogen would be obtained from reaction of 500 centimeter cube of 0.5 molar H2SO4 acid with excess zinc melter.